So we're reaching the end of our training series here. What does it all mean? Let's go through and recap some of the key points. So we've talked about AV as being data, timing, and a shared interpretation. We've talked about IP and how it encapsulates data into packets, adds addressing, and then provides multiple transmission methods, unicast, broadcast, and multicast, to send that data across a network. We've gone over situations when AV over IP is attractive, some of the benefits that it can offer, but we've also touched on some of the situations where perhaps it might not be the best choice as well. So great in some applications, but not necessarily all. AV over IP for us then is very much all about SMPTE 2110, NMOS, and IPMX. So SMPTE 2110 then, this is all about how we pack the pixels into packets. It's when we need to send those packets over the network. So the three different sender types: narrow, narrow linear, and wide. 2110 covers how we should be synchronizing senders and receivers using PTP, typically requiring a PTP grandmaster. And it also covers how we describe those streams using SDP, so that our receivers and our senders all have a shared interpretation of what that video stream actually means. Now, we've touched on the fact that not all 2110 senders and receivers are compatible with each other, and there's various reasons for that. Could be down to the stream types, could be down to exactly which parts of the standard the sender or the receiver has chosen to implement. And we've talked about the fact that your media network needs high bandwidth switches, and it's potentially quite complex to get those set up and all working reliably. We then went on to talk about NMOS and IPMX. So NMOS is a protocol that will allow us to register devices, to announce their presence essentially, and then also for everyone else to discover those devices. NMOS gives us a way to set up connections between devices. And NMOS itself is a protocol rather than a product, so it would be implemented by a system controller that then gives you the ability to see what devices are on the network and configure those connections. Separately then, we've talked about IPMX, and IPMX targets the Pro AV industry and interoperability between devices. And IPMX is built on top of 2110 and NMOS, and indeed mandates that you must use both of them. It states that you should use PTP if it's available, but also it can operate without PTP, and still you can achieve synchronization between IPMX devices without PTP. Now, we've covered a lot of ground here, but we haven't covered absolutely everything in immense detail. So there are lots and lots of specification documents relating to all of these standards, and they go into huge technical detail about how all of this works. We obviously haven't covered these topics in that level of detail, but hopefully in most cases that shouldn't be necessary, and it's certainly not necessary to have this broad understanding of how AV over IP should work. We haven't looked at the specifics of all the ways that things can break. And this is different to baseband video, whether we're talking HDMI or DisplayPort or SDI, all of which have their own nuances. Well, IP brings another layer of complexity to the table. And again, there are different ways that perhaps not every IP device is going to be fully interoperable with every other device. Moreover, it's not just down to the devices themselves, but now also the network that you have in the middle, and how that can impact interoperability. We talked briefly about what Brompton is going to do in terms of what we are supporting on our Gen 3 processors. We haven't gone into huge detail there, though, in terms of how that's actually going to operate and how you drive that. We will be providing more information on that in due course. So hopefully, if you have watched the video series end to end and you've stuck with it, thank you for that. Now, I would hope you're able to at least talk about the basics of AV over IP in the broad sense. You understand why AV over IP is something that we should be caring about, but maintaining a balanced view. So what are the advantages of using AV over IP, but also what are the situations where perhaps there might be another way of solving the problem. Hopefully now you understand the basics of actually how we transfer AV over IP, both in terms of the video data, but also the timing, and of course, how we ensure that senders and receivers have that shared interpretation to make sure that we can coherently reconstruct a video signal. We've looked briefly at what an AV over IP system might look like in practice in terms of senders, receivers, network switches, and typically also a PTP grandmaster, and how we might manage that using something like NMOS. But realistically, we've not covered absolutely everything there could possibly be to know about AV over IP. It is an extensive subject. The hope here is that we have given you an appropriate grounding into all of the technologies that are required to make AV over IP work. Thank you very much for watching. Hopefully this has been useful, and we look forward to answering any questions that you may have on the subject of AV over IP, or indeed any other related questions as they relate to the Brompton product range. So if you do have questions, please do reach out to us, come and talk to us. We're always very happy to chat through the details. Thanks again for watching, and we'll catch you again in the next one.